All right. In this video, we're going to cover products and quotients of complex numbers in trig form. So take notes. Last section of notes for the semester. Well, it's broken into 2 videos, though. All right, so 8.3 products and quotients. Products and quotients in trig form. So this first video, we're going to look at just products and quotients. And then in the second video, we're going to look at powers of complex numbers in trig form using de Moivre's theorem. Okay. All right. So we're going to look at multiplying, dividing in trig form. And then we're also going to look at powers of complex numbers. And when we look at these powers of complex numbers, we're going to be looking at de Moivre's theorem. Okay. So again, this section is broken up into 2 videos. This video will cover this first part. Second video will cover powers of complex numbers. Okay. So let's take a look at multiplication, division. All right, so if you have this first complex number, so we're going to look at multiplying and dividing between 2 complex numbers. So we're going to call them Z1 and Z2. So suppose Z1 is this complex number, cosine theta 1, I sine theta. Here, that's kind of messy. And let's let the second complex number be R2 cosine theta 2 plus I sine theta 2. Okay, so here are our 2 complex numbers. Then Z1 times Z2 is going to equal, this is a nice sweet little formula, R1 times R2 and cosine of theta 1 plus theta 2. So that's nice when it's in trig form, right? So all you do is multiply the 2 r's and then you add the 2 angles, okay? And then for division, if we do Z1 over Z2 divided by Z2, then we're going to do R1 divided by R2. And instead of subtracting the 2 angles, then we will subtract them, okay? Subtraction is not commutative, so just make sure that you subtract in the correct order. Whereas adding up here, it's commutative, so the order doesn't matter. Here it does. Okay. Okay, so that's all there is to it with the multiplying and dividing. So let's do some examples. Let's go ahead and multiply these 2 complex numbers. Suppose you have 4 cis 20 and 3 cis 55. Okay, so if I multiply these two, 4 cis 20 times 3 cis 55, then all I have to do is multiply the 2 r's, so 4 times 3, and then all I do is add the two angles. And so we would get 12 cis 75. Final answer. Okay. So that's it. And again, you could write this the longer way, but why would we do that, right? This notation still gets me. And like I said, 27 years of teaching, I've never seen this. Okay. But I guess this is like the new, like, texting version of complex numbers, right? Everything's getting shorter. All right. I don't mind it. I like it. Less writing. Okay. Find the quotient. Find the quotient. Find the quotient. 20 times cosine 75 degrees plus I sine 75 degrees divided by 4, cosine 40, I sine 40. Okay. All right, so if we're going to do this quotient, 20 cosine, I'm just going to go ahead and rewrite the problem down here. Here, how about if we do this? We'll rewrite the problem here, but let's write it in the short form. 20 cis 75 divided by 4 cis 40. Okay, so then we do the division between the r's, 20 divided by 4, and then we go ahead and we subtract the angles in the proper order. Okay, so then we end up with 5 cis 35. Okay. All right. And you can use either the long way or the long way of writing this, like this, 20 cosine, or you can use the cis method. Okay. Let's take a look at this next example where your complex numbers that you're trying to multiply are not in trig form. Okay, so we're going to do this. Find the product of Z1 and Z2 in standard form. So we looked at this in the previous section, I think it was. In standard form, I think 8.1. Then write Z1 and Z2 in trig form and find their product again. This is so you can take a look at the two methods and see how they compare. Trig form and find their product again. Okay. All right, so here is Z1. Z1 is 3i. Z2 is 2 plus 2i. Okay. All right, so standard form. So let's do standard form here first. So Z1 times Z2 is going to be 3i times 2 plus 2i. And so that will give me 2 times 3, that's 6i, plus 6i squared. 6i squared is going to give me 6 times negative 1. That's just going to be negative 6. So I'll put the negative 6 first, and then because that's the real part, and then the imaginary part. Okay, so that's doing it standard form. Okay, so now we need to do it in trig form. So first of all, we need to convert it to trig form. So let's write those two down again. All right, so Z1 is 3i. 3i looks like this. Okay, so here we can get the r and theta. So r here is 3 and theta is 90 degrees. Okay, Z2, what is Z2? 2 plus 2i. 2 plus 2i. So that's this here. And okay, so we're going to need to do a little bit of math here. Okay, r squared is 2 squared plus 2 squared. R squared equals 4 plus 4. R squared equals 8. So r equals to square root 8. Just going to leave it as square root 8 for now. Okay. Theta, I'm going to need theta equals tangent inverse of y over x. So tangent inverse of 1. So that's going to be 45 degrees. All right, so Z1 is 3 cis 90. And Z2 is square root 8 cis 45. Okay. So then the product, Z1 times Z2, is going to be 3 cis 90 times square root 8 cis 45. And so we do 3 times square root 8 cis 90 plus 45. And that gives us 3 square root 8 cis 135. Okay. All right, I'll go ahead and simplify the square root 8. Square root 8 is 2 square root 2. Okay, so then that is going to give me 2 times 3 is 6 square root 2 cis 135. Okay. And if we work this out, this should be equivalent to what we get up here, negative 6 plus 6i. And it is, because this is going to give us square root 2 over 2 for cosine. Negative square root 2 over 2. Here, let me show you. 6 square root 2 times cosine 135 plus I sine 135, right? All right, 6, we're just checking to see if they are equivalent. Okay, 6 square root 2, cosine of 135 is negative square root 2 over 2. Negative, okay, so we memorize it as square root 2 over 2, right? But this is the same as 1 over square root 2. This is just 1 over square root of 2 with the denominator rationalized. Okay, so I'm going to rewrite it as 1 over square root 2. And a sine of 135 is positive 1 square root 2. And if we multiply these out, the square root 2's cancel, so we get negative 6 here. And then here we get 6i. And we see that this indeed does match the answer that we got up here, negative 6 plus 6i. Okay? All right. But either way, some of the problems will say rewrite the complex numbers in trig form and then perform the multiplication or division. Okay, so just be aware of that. If it tells you to convert the complex numbers to trig form first, make sure you do that. Okay. All right, that is it for multiplying and dividing. If I wanted to divide these, then I would just do 3 divided by square root of 8, 90 minus 45. Okay, so that's all there is to it. If you have any questions about multiplying or dividing in trig form, make sure you email me.